This is Skills Practice 36, or gases and moles. Your first question gives you the temperature, the pressure, and the volume, and you're asked to find the moles of gas in his lungs. You use the equation PV equals nRT. You solve the equation for N since you're looking for the moles. Use the volume, the temperature, and the pressure. You plug in all your variables, including the ideal rate constant, which gives you 0.343 moles. The second part of question 1 gives you the temperature and the pressure, and you're looking for the volume. You use the equation PV equals nRT. You solve the equation for V since you're looking for the volume. You convert the pressure to ATM, you convert the temperature to kelvins, and you plug in all your variables, giving you 8.68 liters as your volume. Question 2 gives you the moles, the liters, the pressure, and the temperature, and you want to find the ideal rate constant. You use the equation PV equals nRT. You solve the equation for R since you're looking for the ideal gas constant. You're given P, T, V, and N. Plug in all of your variables, and you get 0.104 kilopascals liters per mole kelvins. The third question gives you the pressure, the temperature, the grams of a certain gas, and the volume. And you're looking for the identity of the gas. You use PV equals nRT. You set your equation equals to N to find the moles. You plug in your variables. You're giving you 1.32 moles. Then to find the molar mass, you divide 51.9 grams by the moles you found to give you 40.004 grams per mole, which, when looking at the periodic table, shows you that the certain gas is argon. Question 4 gives you the liters, the pressure, and the temperature, and you're looking for the mass. You use the equation PV equals nRT. You solve for N since you're looking for the moles. You plug in all your variables, and you get 4.32799 moles of oxygen. But to find the mass, you multiply the 32 grams of oxygen per mole times the moles of oxygen to give you 132.5 grams of oxygen. Question 5 gives you the milliliters of oxygen gas, the temperature, and the pressure. And you want to find how many moles of oxygen or gas were produced. Use the equation PV equals nRT. You solve for N since you're looking for the moles. You convert volume to liters, and you plug in all your variables to find that 0.00715 moles of oxygen gas were produced. In part B, you're looking for the molar volume of the oxygen or gas at the conditions in the laboratory. You set a ratio, which is PV over T equals to PV over T2. You use your variables at STP, which is a standard temperature pressure, and for the second ratio, you use the temperatures. You use the numbers you were given in the previous problem. You plug all of those in to find the volume, and your volume is 24.5 liters. For question 6, you're looking for the molar volume of a gas at 135 kilopascals and 45 degrees Celsius. You again set a ratio using STP as well as the numbers you are given in this problem to find the volume. You plug in all of your numbers to get the volume, and you get 19.6 liters.